In our last video, we saw how two vectors can be decomposed and represented by a third vector, or the combination of the two, not really a third. And we saw that if you were to draw a parallelogram, you could imagine that the combination of these two vectors is this vector. We also found that you could break this vector into its components called decomposition or resolution, and it would be its horizontal and vertical components. The horizontal component would come over this way and be represented by the green arrow or vector. The vertical component would come up this way and be represented by the red arrow or vector. Question is, how do you get those red and green vectors in order to be able to add them in order to numerically come up with the correct combination vector? It's interesting to note that since we're using the force table, and the force table does not limit itself to one quadrant, doesn't go from just 0 to 90, or 0 to 180, or even 270. It goes 0 to 360. So, the easiest way, I believe, to find the red and the green, or the vertical force component and the horizontal force component of this force F, we can call the red Fy, because y is the vertical axis. We can call this Fx because x is the horizontal axis. The simplest way to get those is to have this angle known as theta. In our case, it looks like this might be 35 degrees, equals 35 degrees in this particular case. The simplest way to get your green and red over and up, horizontal and vertical, is to calculate Fy equals F times the sine of theta. In this case, theta is 35 degrees. The easiest way to calculate, or an easy way, perhaps not the easiest, to calculate your Fx is to take this F and multiply it by the cosine of theta, in this case the cosine of 35 degrees, and you will find the vertical component and the horizontal component of this force. If this force, say, were 50, of course, we would substitute the 50 for these two forces here. If it were 50 newtons, it would be represented in newtons. In the force table, in order to simplify the calculations, we don't make the leap to newtons from grams. We do all of our calculations in grams.